When working on a project or building something new, sometimes you need more hands to handle more things. For many of these tasks that you need help with, here comes the helping hand. There are different types of helping hands that you can use for all sorts of tasks. This one is from KOTTO and I got it from Amazon. As you can see in this specific one, you can see an alligator clip and it's attached to an arm, and there are 4 arms here attached to a base, and at the bottom there are 4 feet. I intend to use this primarily for mechanical and electrical mounting and prototypes when building my robot. Since in this case more is better, I actually got 3 of these helping hands. Here I'm going to talk about what is a helping hand, what are its applications, more details on the specific helping hand product I have here, and other alternative helping hand products in the market. I'll delve deeper into how to use a helping hand, especially for soldering. However, what is a helping hand first? A helping hand is a tool that's used mainly to hold components, parts, or printed circuit boards in place while you solder them, essentially giving you an extra hand to manipulate items while your other hands are occupied with the soldering iron and solder. But soldering isn't the only use for it, as we will describe shortly. Helping hands can be called other names too, such as third hand, a PCB holder, a helping station, a soldering stand, and other names. In electronics, a helping hand can be used to solder or assemble components on a printed circuit board, PCB. To show this, here is a soldering iron, a solder, and a printed circuit board. If you want to solder a through-hole component like this axial resistor, this radial ceramic capacitor, this crystal oscillator, or these headers on this printed circuit board, PCB. As shown in this diagram, to solder a through-hole component to a printed circuit board, you basically insert its leads through the drilled holes in the PCB. And on the other side of the PCB, you solder those leads to the corresponding pad. Okay, let's say I want to solder this 2-position through-hole header onto this printed circuit board. Let's say I'm gonna insert it through these drilled holes over here. To do this, I first will lower these 2 arms since I'm not gonna use them for now. I'll use these 2 arms to hold the PCB in place, like so. I'll use this clip over here and this alligator clip over here to hold the PCB in place. And now I'm gonna tilt it backward this way and place the 2-position headers through the 2 holes over here. I tilted the board this way so that the component stays in place. So I can start soldering on this side, or for extra stability, I can use 1 extra arm of the helping hand to keep the component in place while soldering, like so. From this side, you can see the alligator clip pushing the component inwards, and here we do the soldering, like so. The other type of components that you might need to solder on a printed circuit board are surface mount components, like this microcontroller chip and these small LED chips and other chips in this board. As shown in this diagram, a surface mount component is being placed on one side of the PCB, and there are no through-hole leads. And simply, once you place the component, you can solder its leads to the pads on the same side of the PCB. So to solder a surface mount component onto a PCB, again, we can use the helping hand to hold the PCB in place, like so. This time we can push the PCB to be placed horizontally, like so. Once the component is in place, you can secure it further using another arm of the helping hand. And then you solder away, making sure that once you solder the first pin, the component is in place and it won't move. And then you can progressively solder the other pins. This is one way to do it. The other way is to use a hot air rework station. Basically, instead of solder, you would use solder paste, and you would cover the pads with solder paste first, and then you bring in the component for soldering and you place it in the proper spot, and then using the hot gun you heat those pads, and the solder paste will turn into a solder joint basically, and that's it. In addition to soldering and assembling components onto a PCB, you can use helping hands to solder wires to inline components and panel mounted components, in addition to soldering wires to to connectors and terminals. For instance, as shown in this diagram, you can see a panel mount rotor switch held by a clamp. In our case, we can use a helping hand to mount this switch. And there are a couple of wires that you want to solder or connect to that switch. And in this case, you use the helping hand to hold those wires in place too, while you solder or while you mount them onto the switch. And here you can see how to crimp or solder a terminal. In this case, it's a female spade terminal to a wire. Again, the helping hand can be used to hold the wire in place and the terminal in place at the same time, while crimping or while soldering the terminal to the wire. And here it shows soldering a bunch of wires from a cable to a connector. In this case, it's a USB connector. Again, a helping hand could be used to hold the cable in place or one of the wires and at the same time holding the connector in place and bring them in close proximity and then use a soldering iron and solder to make solder joints. Another use for helping hands is to solder two wires together. Basically, the helping hand would hold in place each piece of wire and bring them in close proximity to each other. Then you twist the two wires together and then you apply a solder joint. There are two popular ways to twist the two wires together, and they are shown here. One is the X-shaped twist and the other is the V-shaped twist. Other than electronics, a helping hand can be used in the making and repairing of jewelry. For instance, again, using soldering, two metals can be joined together by melting the solder material between them or add parts to a piece. Of course, this could be used to hold two other types of metals together for other purposes, such as building mechanical structures for your projects. In general, helping hands could be used in all sorts of intricate crafting, building models and prototypes, and assembly applications where precise alignment is important. For instance, helping hands can make our job easier, assembling this vintage tin toy robot or this low-poly purple unicorn made of paper. The materials that are at our disposal to create, make, and build are numerous, and a helping hand can make our job way easier. For instance, we can use all sorts of paper and cardboards. We can use strings, ribbons, beads, rings, and all sorts of fabric. And we can assemble all types of wood, metal, and plastic parts together with the help of a helping hand. And the same goes for materials like rubber and leather. Obviously, these pieces and parts that you intend to assemble or put together, whether they are of the same material or different materials, should not be too big or heavy for the helping hand that you are using. If indeed this is the case, then you should use another type of a helping hand or another type of a clamp or a mount or a holder. Actually, this is an idea that's worth exploring further. Viewing a helping hand as another type of a clamp or a mount or a holder that can hold two pieces together for a duration of time while a process is being done on those two pieces. Once we think of helping hands in those terms, you start to realize that the potential applications are truly limitless. To imagine those potential uses for helping hands, check these examples for clamps, mounts, clips, vices, and other devices that can hold two or more pieces together. For instance, binder and normal paper clips, different sizes, shapes, and colors of clothespins and carabiners. And there are a bunch of other clamps and holders that are used in woodworking, such as C-clamps, clutch clamp, spring hand clamp, locking plier clamp, spring mitter clamp, locking chain clamp, and table clamps. The processes that you can perform on two or more pieces while they are being held together are numerous. For instance, these processes could include soldering, gluing, cutting, drilling, sanding, finishing, painting, milling, routing, and many others. Once again, those pieces that you intend to use should not be too big or too heavy for your specific helping hand. There are many different types, shapes, and sizes for helping hands in the market, and you need to pick the one that most suits your intended use. As I have mentioned before, the helping hand I have here is from KOTTO and I got it from Amazon. And certainly this specific helping hand won't be suitable for all the applications I enumerated, but for the type of applications I intend to use this helping hand for, this helping hand is ideal. As mentioned before, the specific helping hand I have here is from KOTTO and I got it from Amazon. First, let's check its Amazon product page to know more about it. Here is the product page for the KOTTO helping hand on Amazon. As you can see, the title here focuses on the brand name KOTTO and that it is a helping hand and that it is used for soldering, crafts, and jewelry, and that its heavy base is made of steel. We can next go and check the KOTTO store and see what other products they sell on Amazon. On the KOTTO store webpage, we can scroll down and check for more information. We can see that they focus on selling hand tools, solder and welding tools, and lawn and garden tools. I'm most interested in the first two types of tools. And if I scroll further down, I can see their best sellers on Amazon. I happen to have purchased the first products of their best sellers here, namely their solder fume extractor, the soldering pump, and of course their helping hand that I am discussing here. Now let's go back to the KOTTO Helping Hand product page on Amazon. You can see that this helping hand has good reviews with a rating of 4.5 out of 5 given by more than 5,500 customers. Its price today is $23.99, which is very reasonable compared to the others. You can see there are a couple of different KOTTO helping hands offered here. In addition to the one that I have already purchased, you can check another helping hand offered by KOTTO, this one. You can see that it has in addition 4 magnetic pillar holders, a soldering iron holder, and a PCB clamp. Back to our specific helping hand, you can see that it has other images included. For instance, in addition to this general image of the helping hand, there is this one that shows some features of the helping hand. The next one shows the different parts included in the package. This one shows how to assemble the helping hand. And there are other images included too. These are the main contents of the package that it came in. A steel base, 4 rubber feet, and their 4 mounting screws, 4 gooseneck arms, and 6 alligator clips. Now let's talk more about these parts before we start assembling the helping hand. First, the base of the helping hand. It's made of steel. This makes the helping hand heavy, sturdy, and more stable in use. The weight of the helping hand is 1.26 kilograms, and most of that weight is due to the steel base. Its dimensions are about 20 centimeters by 14 centimeters. It has fillet corners. That is, its corners are rounded at about 4 millimeters radius to be more specific. This makes it look more pleasing to the eye and avoid the use of sharp edges, which might cause injury. The base has 6 drilled holes. Each has a diameter of 5 millimeters. The screws that are used to mount the arms and feet to the base fit through these holes. For reference, these are panhead M5 1x16 machine screws. This means they have a diameter of 5 millimeters, a pitch of 1 millimeter, and a length of 16 millimeters. The base comes in one color, that is, yellow. For me, I would have chosen red if it was available. As for the surface finish of the base, I think it's powder coated. It's textured, which feels nice and makes it less slippery. It also has a matte finish, which helps reducing gloss, which reduces the chance of distractions due to light, while using the helping hand. Finally, the finish protects against corrosion, scratches, and fingerprints. Next, the rubber feet are used to provide extra friction for the helping hand on any surface, reducing the chances of slip and providing more stability. The rubber feet are removable. They can be mounted on any of the holes in the base using the screws we saw earlier. Since there are 6 holes, you can mount up to 6 rubber feet to the base, but I generally use only 4 of them. Next, we have 4 gooseneck arms. When mounting an alligator clip to the end of a gooseneck arm, the total length is about 31 centimeters, which allows for a lot of maneuverability, dexterity, and control when using the helping hands to hold different pieces in different ways. Since there are 6 holes in the base, in theory you can mount up to 6 arms on the base. As shown in these diagrams, a gooseneck is typically made by winding a wire with a triangular cross-section around a central spring made from a round wire, creating friction between the two that allows the gooseneck to hold its shape when bent. Although usually a good solution for holding parts precisely in space, gooseneck arms might not be as stable as other types of supports, such as links and joints, shown here. This might allow for some undesirable wobbling and flexing when using gooseneck arms. Lastly, we have here the alligator clips. There are 6 of them in the package. You can mount one on each of the available arms. These are made of stainless steel. These are silicone or rubber gloves covering their teeth here. These provide protection against accidentally short-circuiting components on a PCB and making scratches on your held parts. These diagrams show how a typical alligator clip is constructed. It basically consists of rigid spring, iron rivets, and the alligator jaws. The alligator clip can be rotated 360 degrees around its longitudinal axis using a thumb nut on a threaded rod or stud. It's easy to set the position of the alligator clip on the gooseneck arm. First, you mount the alligator clip, you turn it around the threads of the arm and choose your final position. Let's say it's at this position, and then start turning the thumb nut until it pushes against the alligator clip. And then the alligator clip is secured in its final position. Few things to watch for when using using these clips and arms. For instance, the clips are not of the parallel type, which would have applied pressure uniformly. Hence, they might in principle cause scratches or bite marks on held objects. Also, the clips are not good for bigger objects, since they themselves are not big. However, in principle, they could be replaced with bigger clips if they can be screwed onto the arms. Finally, it takes time sometimes to move the arms and clips to where you want them exactly to be. And now I'm going to show you how to assemble the KOTTO Helping Hand. First step is to put the base perpendicular on the surface of the table. Then you get one of the rubber feet and you get the proper screw and you insert the screw into the rubber foot, like so. And then you get the screw with the rubber foot. Using a Phillips screwdriver, you keep the rubber foot on the lower side of the base. Then you bring one of the helping hand arms, like so, and you place it on the tip of the screw. Then you start turning the screw from the rubber foot side until both the rubber foot and the helping hand arm are secured in place, like so. And here you have it after I repeated the same process 3 times. The 4 arms and the 4 feet are secured in place. Next, we're gonna mount this alligator clip on one of these arms, like so. First, you thread the alligator clip onto the stud of the arm, and then you set it to your preferred angle, like so. Next, you turn the thumb screw until it pushes against the alligator clip, and now your alligator clip is secured in place at your preferred angle. And here we have assembled the complete helping hand. You can build your own helping hand or buy any of the ones available in the market. Naturally, each of these helping hands have their own pros and cons based on what materials they use, how many accessories they implement, and the type of mechanisms and technologies they utilize. Also, their construction depends on their target application. For instance, helping hands that target soldering and welding applications might be different than those helping hands targeting jewelry and crafting applications. Here I will show 3 alternative helping hands to the one that I own. The first example here involves building your own helping hand. This one is made by Makify on his YouTube channel. It's essentially made of 12-gauge wires and few pieces of wood and screws. Here is a summary of how to build it. First, cut wood into a square piece of approximately 23 cm sides. Next, cut 4 strips of wood to create a frame on top of the wooden square. Glue the strips to the wooden square. Use clamps to hold the strips to the wooden square for the glue to have some time to dry. Use a 12-gauge solid core wire as the arms for the helping hands. Cut the wires to about 30.5 cm length. Strip the ends of the wires. Use alligator clips. Crimp the alligator clip to the end of the wire. For extra strength, solder the stripped edge of the wire to the alligator clip. Make 6 of these alligator clip wire parts. Drill 6 or more holes through the top where you want to have the arms mounted. Drill 6 or more holes on the side of the wooden strips, under and perpendicular to the 6 previous holes from the top. These holes will be used for fixing the wires to the wooden base. Insert the 12-gauge wires from the top side into the top holes, and then, driving screws from the side, those wires can be secured to the wooden base. Add heat shrink tubing to cover the alligator clip teeth, and that's basically it. Here we're gonna mention some of the pros and cons for this DIY helping hand. The pros include, if you have the tools and materials, this helping hand could be built in a short amount of time. The tray in the bottom is helpful in holding pieces that you are working with, or for holding pieces that may fall from your alligator clips. As for the cons, the arms are a little springy. It's not easy to maneuver the arms to get your alligator clips precisely where you need them to be. You need tools to cut wooden pieces into the right dimensions that you may not have, and you will have to buy them separately. Of course, for more details, please check Makify's channel on YouTube. The next 2 commercial helping hands are available in the market and you can buy them right away. Both of them are recommended by Adam Savage's channel on YouTube. This is the first one. You can get it on Amazon. It currently sells at $47.78 and hence more expensive than my own KOTTO helping hands. This is highly recommended by Adam Savage on his YouTube channel. You can find the link at reference R42 at the end of this video. These helping hands seem to have a couple of advantages. First, it appears to be built built entirely from a steel alloy, which makes it sturdy and stable when using it. Also, it has big clips with strong springs. This makes this helping hand capable of holding a wider range of objects with different sizes and holding them more securely. It has long serrated tips or jaws that can hold parts more firmly. These tips are also replaceable. It uses links and joints instead of gooseneck arms, which makes them more maneuverable, flexible, and precise in holding objects at specific positions. The other commercial helping hand that you can get, and that's recommended again by Adam Savage's channel, is this one. Unfortunately, it's not available on Amazon, so if you want, you will need to purchase it from OMNIFIXO, its Swedish designer's website. Check reference R43 at the end of this video. I like this one because it looks like its designers have put in the extra effort to make it smarter and more helpful than the rest of the helping hands in the market. Nevertheless, it's at a higher price point of $66. It's small and compact, best used for holding tiny objects. Also, its features are focused primarily on soldering and not on other general uses for helping hands. As mentioned earlier, this helping hand has a couple of cool features. For example, it uses parallel clamping that rather than pinching a part, it applies even pressure across it, which allows it to have a firm grip even of small objects and wires, with no bite marks or scratches. It uses magnetic ball joints to link the arms to the base instead of screwing them on, which allows more versatility. The magnets are also very strong that their movement is more precise and stable than when using gooseneck arms, for instance. Since the clamps are conductive, you can connect the leads of an external power supply to them and then run electricity through your board, LED, or any other electronic device. In summary, we discussed what a helping hand is, and we mentioned that it's a tool that's used to hold two pieces together until some process is performed on them. And then we discussed its applications, which include soldering and assembling components in electronics, repairing jewelry, and many more. And then we delved deeper into details about the helping hand that I own from KOTTO from Amazon, and we compared it to other alternative helping hand products in the market. Here are references and attributions for materials that have been used here.